Welcome again to Agiliway series of webinars dedicated to technology stacks we've been passionate about and we have been working with extensively. And today we are going to talk about Golang, why your company needs Golang in 2022 and generally moving forward on. And myself, I'm the delivery director in Agiliway, and let me present Anthony. Anthony is a senior Golang software engineer, and we both work together in a number of projects, and I guess it's safe to say we share the passion for let's say technologies that allow agility, flexibility, and speed. So today we are going to talk about some of our passions. I guess those of you who attended our previous webinars know that we usually introduce both the theoretical part and practical side of why we are speaking about certain stack and so on. So the agenda of today's webinar will follow the same pattern. Let's move on to agenda. So there will be a short introduction led by me, and then Anthony will be talking more about why Golang is a cool modern language and its specifics, practical samples, and how can you use certain characteristic features of Golang in your projects at your companies, and a few gotchas that you can, I guess, either kick off from or use in your practical use cases. And then there will be a short Q&A session with the possibility of the further communication if we need more time in the future. So let's start with the introduction. Why is Go so popular? And of course, it's not the only stack and not the only language, and it's definitely probably not one of the, definitely not one of the oldest, it's one of the youngest ones, and still we see the tendency, we see the specific phenomenon kind of Go in multitude of startups these days. And so also in many enterprise endeavors, not just startups. So we wanted to explore and give you examples from our practical life why this language has been so popular. And some of the things you'll hear are probably mainstream. You have already read about them. Some of them will be eye-opening, I hope. But let's start with some things that we decided to single out for the introduction, and then we'll go deeper with them. So first of all, this is definitely the 100% the perfect choice for cloud-based products, and it's pretty straightforward. Anthony will be talking more about simplicity, the easiness of operating with it, and some, let's say, pros and cons of this easiness. It has been extensively used for high-performing applications, and in this respect, it's also kind of logical that it has been infrastructure friendly. It's been kind of definitely one of the best decisions if you want to go into cloud-based, as I mentioned before, this, solutions. And you can consider such popular already tools like Kubernetes and Docker that are already written in Go and can be perfectly comparable with your written applications or products you're working on. Many command lines are written in Go, and basically from our experience, Go has been used perfectly with healthcare, with fintech, with various products leveraging AI and data science, in robotics, gaming, and so on. So from our standpoint and from our experience, samples, examples, and the best practices would all kick off from healthcare, fintech experiences. And actually, it has been pretty great and pretty like a finding for us using Go in solutions for healthcare and for fintech. And it's a wonder kind of, because we know, you know, probably as well, that these two spheres have been quite, let's put it, old-fashioned in a way, and you know, solid, using quite older technologies. So using Go actually speeds things up and opens a lot of horizons for new solutions, for new for the startups, and also for new view on the enterprises and enterprise endeavors. So kicking off from that, let's go deeper into more, let's go one level down into more technological aspects of Golang and its applicability to certain spheres. And Anthony, the floor is yours. Over to you.
Thank you, Vika. Yeah, so I'll be talking about Golang in more like from more developer perspective. Why do I like it? Why I think it worth considering to use in your project or to learn or something. Yeah, so first item would be it's new, relatively new compared to some languages like some popular languages like PHP, Java, C# and stuff like that. And so Golang itself was created like not in the US part, but in 2007 and publicly released in like 2 years after that. But those languages I mentioned, most popular ones were created like 10 or 15 years ago, and having like this newest newer language, it allows creation of this language to not to support some obsolete versions. Also, you know, like when you create some language and you know, support it for several decades, you like create some, you need to support some modern features, and you create some weird ways of using all syntaxes in new version to support to have backward compatibility. So yeah, Go has less of those problems because it's a new language, and it was created by several pretty experienced engineers. Like Ken Thompson was designer and creator of Unix and C. Rob Pike was creator of UTF-8 and Unix format, and Robert Griesemer, he was participating in development of Google's VBA JavaScript engine and Java Hotspot virtual machine. Yeah, so the next item would be Golang is open source language. So it means that first of all, it's free to use, like either for developers or some companies choosing Golang. You don't need to pay any extra money for using it. You don't need you don't have any license restrictions. So you don't need to follow any, you know, license rules or something. You can easily modify it. It's modifiable, so you can, since it's open source project, you can just find its repo and make your own fork and like implement some features you critically need or something. And you can even propose, join the community and propose these features to be added to new versions. So that is cool, I think. The next point would be its compiled language. So compared to some languages like Ruby, Python, Java, it is not interpreted language, it's compiled language. And that means that you don't have some middleware tool that is converting your code into something that your machine understands. And because of that, your program will run faster. And second point would be you don't need to install anything like language specific or land specific on your machine you're planning to run your software, because you just directly compile the code into some executable binary of your target machine, and it will just run, and you don't need to install anything except you just don't need anything. Yeah. Also, it may be disadvantage for somebody when you don't have on-the-fly updates in Golang, because you need to compile your code into binary each time you do some changes, but the language itself was intentionally designed to have super fast compile time, and yeah, and it was achieved by some of these points, like you don't have ability to have like dependency cycles. Like if you import some dependency that like dependency A that imports B and B imports C, then it means that dependency C cannot import A, because that way you will have like the dependency cycle. And then you cannot have unused dependencies in your code, and having some unused dependencies will be considered as compilation errors. And if your IDE is smart enough, it will say it's an error and just automatically remove it, so you don't have some garbage in your code. By the way, you have the same works for variables. You cannot have any variables you don't use, and we'll see like some examples later. And then you don't have separate header files for your dependencies, as you have in C++. All the dependencies are imported like directly in your code. Like in the same file you have your code. And the last one will be simpler syntax. So Golang has only 25 keywords, and that means it's easier to understand for and to translate for compiler, but it also means it's easier for human to understand. And that would be the next our point. It is easy to understand, and has human-friendly syntax. The things I like the most is you don't need to use end of lines, so because like modern compilers just knows when your statement ends. Then you don't need to use round brackets in your if statements, and then that gives you like the if statement itself reads more clear, like usual sentence. And then you have optional variable declarations. All variables have are typed, but there is no request that you like specifically clearly say the type of the variable you are declaring, because you can do the declaring and assigning in the one line. Just the type will be just chosen automatically. But of course you can still use the clear declaration. Next point would be controlling of visibility. You don't need like any specific keywords to say your function will be, or constant or whatever will be visible from outside of the package, we call it in Golang. So you just use like the first letter of your resource to say is it public or private. Then you have one cycle operator for everything. Like you just use different syntax for while cycle or for do while. You just define the difference in the code block itself. Then you have default break operator in switch, and that is very nice feature to have, because I used to code using Java, and there were several times I spent like some time, I know, like half an hour to debug my code and to understand what went wrong. I just forgot to use some break operator or something. Even the end of line, it sometimes takes like a few minutes to understand what is wrong with this code. And then the last one would be error handling in Golang. So in Golang, error is a value, the same value, like you have string or integer or something, and this value will be, it's usually returned by some functions, and you just check that value. And if it's not empty and something went wrong, maybe, so that makes error handling more clear, because you like clearly check if you have had some error. So yeah, let's see some example of mentioned previously. So in this example, we have like super simple code. We have a main function. You see imports are all here, only one import. So in the main function, we call just one function inside. And this function, as you can see, returns multiple values. So it's like usual thing in Golang to return some business value you'll use later somehow, and the error value. Yeah, so and then you after calling the function that return an error, you just check if you got some error, or and if there was some, you just do the error handling in this block. But if everything was okay, you just like continue using your business result. Let's call it like that. And yeah, and so here you can see like the two ways of variable declaration. You can do it like you can just declare the type and it will be the default value, and you can easily like declare and assign value already to the some variable. Yeah, so for in this example, I made this cycle as in while style. It may be not the best solution, but I just wanted to show that you can use like for cycle in multiple ways, and the usual for cycle will also work. And yeah, and here you can also see like the if statement is a little different than in some other languages, but the main difference would be in this example, it's some let's pretend it's some business logic. We are searching for some value we pass, and we have here some, let's say, hard-coded range that will be that is acceptable. And if during this search we didn't find the value, we just return empty result and return an error. So for example, and if everything is okay, we just return the business value as something, and empty error. So yeah, and then we check it and do some stuff. So we can see that if we use, for example, 7, everything is okay, and we just print the steps, and during step number 7 we just returning the value. But if we do something bad, like we search for 70 in 10 range, we just we just go into this statement and just handle error somehow. So yeah, that's for the error handling in Golang. The next point would be simpler version of object-oriented programming in Golang. So there is no usual way of object-oriented programming in Golang, but we have some concepts that are replacing those. And I would say for me, it's even simpler, and you don't have to convert somehow your business model into this object-oriented stuff. It just easily suits the real world. So for encapsulation, as I already mentioned, we have this first letter case to control visibility, like private, public. For inheritance, we have a struct embedding. So in Golang, we don't have classes, but we have structs, and it's pretty much the same concept. We have that the struct can contain some fields, and you can also have some methods that this structure will be, executed like you have an object of class. But for inheritance, we don't say explicitly we inherit something, but we can embed one structure into another. So that way, all the fields and all methods will be inherited, and we will see an example later. And for polymorphism, you don't need to use any specific words or keywords to say this structure or type implements some interface, and this does not. You just define some function definitions in your interface, and each structure each type that has the same functions, the same definitions, that they will be automatically implemented in the interface. So yeah, let's see example for that. Let's keep this part for now, interface part. So we have here some common structure named person. It has a field of name and phone, for example, and we have also student and teacher, and both of them are persons. So we embed person information, person methods into both of them. So also you can see how these methods of person struct that is doing some logic. For example, this one is just printing the name, some hello message with the name of the person. And so you can see we just embed the person into student and teacher, and add some custom fields to both of them, like some business specific fields. And also for teacher, we also have some additional methods that will add the course into existing courses. So both of these structures will have the say hi method, because they are let's say inheriting the person, and teacher will have this additional method. So here you can see we can use also person, of course, like a standalone structure. It will have this say hi method. Then we define this student structure, and we see we have here embedded person. So we can reuse, and we reuse here its fields, and then we have this custom fields for both teacher and student. And you can see like both of them have this method, and here we have this custom method. Yeah, so let's run it. So you see we have like these three different names printed, and new course added. And then let's define some interface. Let's call it greeter interface, and it will have this say hi method. And if you can see right now, IDE already sees that this interface was implemented, but you can see we didn't say anything like here to, or we want to implement that interface. It's automatically implemented. All these three structures will have this method implemented, since these two inherit this from person. And yeah, we can prove it. For example, let's make this student of type person. We can't use it as a person. Oh, sorry, not a person, but greeter. Yeah, so we have this greeter interface, and as usually in all like programming languages, we can then pass this let's say object of this structure to some method that will be accepted into this interface. And of course, if we make this Jerry a greeter, this method add course will not be now available, because we need to, we restrict like the scope of it to this greeter, to have all of these interface methods. Okay, let's move on. So the next cool feature about Golang, I would say, it's super easy concurrency. You don't need to care a lot about like managing your memory, or managing not to do some race conditions or deadlocks. You of course can manage to have them, but it's a lot easier with out-of-the-box constructs to prevent it. So the main feature in Golang for concurrency managing is channels. So that's some specific type that this specific type is like thread safe. You can use it in multiple coroutines. Coroutine is you can consider it like a thread, but it's some super small thread that just can be executed concurrently with some other ones. So yeah, these channels are connected to several. They can be connected to several coroutines, and in each of those you can either send or receive some data. And like you can imagine it like some pipe, and that pipe is connected to those coroutines. And to start to start a new Go routine, you just use Go operator, and it's super easy to manage. Like you just say you have some function you wanna run in separate thread. You just say Go, and that function name, just call it as usually. We'll see example in a bit. Then you have out-of-the-box timeouts. You can manage your execution time using them, using this construct and this select operator. Because using this select operator, you can like wait on some multiple concurrent actions, and when one of them like finishes, either you receive some data or you have this timeout, you will receive some result, and depending on that result, you can do your other steps. Let's see an example of that. So again, let's keep for now this commented part. So in this example, we are creating channel. The channel will accept like values of type string, and we have this function. We wanna do something like, let's pretend we have some long execution process. We want to like start this execution in separate thread, and send some result to the channel after it was executed. For example, it takes us 10 seconds. I know maybe it's some it uses a lot of computing resources or something, or some external resources calls. So here I made something like some ticker, like every second we have this select operator in which we say we wanna receive something from this channel, but if you don't receive anything, like right now anything was written to this channel, we'll just default to printing some waiting message and sleeping for 1 second, and this is run in like infinite loop, and so it will run it will be running till we receive some results. So and here we actually start the separate coroutine. So when we start this, we see we are waiting for like 10 seconds, and after 10 seconds we will receive the results from this coroutine. And yeah, so we received this value here in this case. But for example, if we don't want to wait like forever, maybe this never executes or something, we can just have this, when you can get, get rid of this waiting stuff, can get rid of this for cycle, and now this select operator, it is blocking operator. So if we don't have any default value here, it will be just blocked by the time any of these is like true. So we either wait 7 seconds and time out, or we receive some value. Let's make it actually like 3 seconds, so we don't wait a lot, or we'll receive some value. So yeah, we see after 3 seconds we didn't receive anything, so it's timing out, and let's make it 6 seconds, and after 5 seconds we should receive some result and print it to the console. Yeah, so we have it. Yeah, that was about coroutine, but sorry, one more thing. So I would like to show you one more example, a little bit complicated, more complicated, but it's more like business version of coroutines and what you can do in parallel. For example, we have this already know that we have these structs, and we have some employee struct with name and salary, and we define here like we have 5 employees, and each of them have like their own salary. And let's imagine we need to process each of these employees in some we want to process them in parallel in some separate thread, because maybe that takes us some computer resources or external calls to do this calculation. So we are again defining the channel for processing of those employees. This time we are making this channel buffer channel, so we can like send a lot of, let's say, requests to this channel, and we define it like capacity of this channel, so we can send a lot of data to this channel, and then we'll need to somehow read from it and execute something, and then collect some results. So this is another construct we have in Golang. It calls wait group, and wait group does what it says. It just waits until something is finished or resulted, and we define this wait group. We add to this wait group some number, and this number will indicate how many like results we want to receive, how many time of this wait group has a method called done, and we pass this wait group to our like workers, and this when we call this done method, we are notifying that we processed this employee item, and this third method this wait group has is wait method, and it again is blocking method, and it will wait until all of these done methods are called, and this like the number of done calls equals to this length we added. And another thing, let's say we have some limitations here. We don't want to process, for example, in this case we have only 5 employees, but in real world we have like thousands of employees, and we don't want to process all of them in parallel, because maybe we have some resources restrictions, like we maybe have some we don't want to like spend a lot of computing resources and just burn our some database or application. So we are saying that we want only 3 workers here. Of course, it should be moved to some constant, but I want to keep it here. So we just start 3 workers with some name of the worker in parallel by calling this worker function with Go operator. So we'll have 3 concurrent executions. They will be connected to this channel, and while there is some data and channel isn't closed, we are closing it immediately, but there is some data to process, so our workers will try to fetch some data, so we already know what is the select and why do we need this for cycle. So it will run until we have we can read something from this channel, or it is closed. So if we read all the data and we have nothing more to process, this worker will be finished, and this and this all these 3 threads or Go routines will be done. So here we have some simulations of long processing, just to not finish everything like in half a second. And we process our employees, just adding 10% to each salary. And so let's just run it and see what we have as a result. So we see 3 workers have started, and so as a result we see all 5 employees were processed their salaries. So we started only our 3 workers here, and when like this 0 and these 2 were done, they picked up new employees to process, and the 3rd one, like this worker number 1, didn't do anything else because we had only 5 employees. But the main thing here would be if we remove like all these test data and all these prints, we'll have like and all this result printing, we'll have like 20 lines of code, and these 20 lines of code just run your stuff in parallel and managing your execution resources, and that's pretty cool thing of Go you can do. So let's move on. When you use Golang, you of course, as with any other language, you need to be aware of some stuff. For example, as I mentioned previously, unused variables are compilation errors. So this actually this is maybe considered as a restriction, but actually it's good for your code to not forget anything, like to process anything, because for example, if in this case we would forgot to handle this error, we would never know if anything went wrong during this processing. So you cannot just run your code with this unused variable, and that's really cool because I also had some cases when I forgot to use some variable because I thought I used it, but I wasn't. So yeah, and that's cool. And yeah, but if you don't want to use some variable, just you have like some you want to do some test or something, you can just assign this variable to blank identifier, and this error will go away. Then another example would be there is variable shadowing in Golang. For example, if you can define the variable with the same name in multiple contexts. For example, let's see this stuff. So we have here some person, and we have, let's not use this method for now. We have some variable p, and we assign it to some person, printing it just to see if everything is okay. And then we, depending on some condition, we just wanna reassign its value to something because we just need it. And you see here, even your IDE is showing you this variable with some weird color, and if you go and click on it, you search for context actions, you see that that the variable was shadowed, and that means the p here is not the same p you declared here, because here you are redeclaring by this and redeclaring and assigning new value to this p variable. So you should be aware of that. And right now, if you run this code, it will see you will see that the value during this second print was the same we declared here, but not the reassigned new variable here. So just to fix it, we just need to make not declare and assigning, but just assigning to the variable. And next one would be that in next item would be that in Golang we pass everything by value. So here, if you, sorry, that was already fixed code. So here, if you have this method, for example, change name, you want to change some field of your structure, and you are passing, like, you think you are passing your structure and like new name we want to change it to, this wouldn't work because you are not passing the you are passing actually the copy of this structure, and here it will be changed, but it will be changed in the copy, not in the actual value. So to make it work, we need to pass the pointer to the structure. So it will this method now accepts not the copy, but the pointer to the memory where we have this variable, and we see everything is okay right now. And the last thing would be, if you read something about Golang, you already know that in Golang we have something called slice, except of usual arrays. And for new people, it may be like some problem with arrays, because arrays in Golang is just some static thing that you cannot extend, or you cannot extend. But the main problem would be when you send the array in Golang to some function, you will again pass the copy of the array to this function, and everything you change in this array will remain in the copied array. So you just need to be aware that this syntax is for arrays and this one is for slices. Slices in Golang is just dynamic arrays. They have some length, but they can be extended, or yeah, they can be extended. And when you pass the slice to the function, it will be again not the copy of the slice, but the pointer in the memory to the slice. So if we do this with arrays, we see nothing changed, and this 999 wasn't assigned to third element. But if you do it using slices, everything works. Just need to be aware of that. Yeah, so I guess that was all I wanted to share with you, but just the last thing, because a bit before questions and answers. So I will say that at the end of the day, programming language is just an instrument, but Golang is just very comfortable and very fast one. So yeah, choose your language. So okay, I guess Vika is out. So maybe we can move to the questions if anybody has anything to ask. I will stop sharing my screen. Yeah, I see we have one question in chat. What are the benefits using Golang comparing to other languages? So from the developer perspective, it just for me is just the easiest language I was using for my like in my career. So it's really straightforward. If you also have some needs to do some concurrency, or you have some high loaded project that you want to run it super quickly, and also if maybe you don't want to, you have your own maybe server or something, or you want to use some existing ones and you don't want to care about like if you want to use Java, you need to install some JVM or something. You need some third-party tools to run your program. So I would say it's just fast, easy to use, and really comfortable to use. And third one would be, as Vika mentioned, is infrastructure friendly or something. Okay. Is it possible to use counters of force when working with Golang? So for semaphores, actually this if you saw this working group I was showing you in that example, it is like kind of a semaphore, because you can using it, it's thread safe, and you can use it to like have some specific number of like of anything you want to process. But yeah, also you can use like you can have some specific can create some specific channel for that purpose, and in that channels are by default thread safe, and you can say that channel would be like has a capacity of 5 elements, and you can have your workers to write to that channel. And once the channel is full, and your new workers will not be able to write to that channel again, so they will need to wait until something is some other process reads from that channel, and then in that way you can control your resources. So that's also like a pretty common task in Golang, so you can find like a lot of examples how to do it. So it's really easy. Yeah. When it comes to AWS Lambdas, how much faster is Go Lambdas that, for example, once written in Python? I'm not sure for the comparing. I guess you can just Google like some graphics or something. But as I know, like Golang is by default it should just spin up faster. So you definitely will have some win, but I'm not sure like is it like 30 or 50%, but that should be something like that, I guess. Other frameworks that are worth learning for Go. Have you used any frameworks in Go? So I personally don't really like any frameworks when you can do your stuff without them, because each framework is like, it's not it adds some additional complexity for anybody who's working with it, because when you use some framework, you need to know like what limitation it has, what you can do, what you can't do. You need to invest some time into learning it, and also it may have some the frameworks are written also by some people, and there may be some bugs also, and for your use cases maybe nobody else saw these bugs before, but we have several cases where we had some problems with like we spent actually, I don't know, maybe more time on figuring out what is wrong with the frameworks. That time we might invest into something we write by ourselves. But for Golang, we were using some like Gorilla Nux framework for HTTP. I'm not sure if it's considered as framework, but some Golang database tools. So I wouldn't say there are some frameworks you need to learn like to have better experience in Golang. I would rather recommend to learn some third-party technologies like some cloud solutions or something moving to that way, because that will you will use that with a higher probability than you will use some framework in your next maybe job or something, or project. Yeah, I guess that will be our final question, and good one. How to debug concurrent code in Go? So actually, my latest experience with concurrency in Golang was like not really nearest time, but you can always, like we had in this example, you can always use some additional logging, some naming of your workers, some I guess additional logging would work in all cases. And yeah. Okay, so I think we can finish our webinar. So all the resources, we will share some resources, some links with you if you want to start with Go, or you want to see some interesting examples in Golang or something. We will share that information with you, and maybe some contact information and stuff. Okay, thank you guys. Thank you for coming. See you in Agiliway.